Lily. Right, okay, complex numbers, Argand diagrams. It says there, write in words the locus L1 of points representing the complex number W, which satisfy that thing. So draw and label a diagram showing L1. Right, basically, that is saying, you'll have probably been told, oh, let me get a pen. Oops. Right, so W, let's call him Wally. Wally, the difference between Wally and this complex number, which would be 0 plus 9i, and then end that one, equals W minus, let's just write this out first and then I'll say it again. So basically Wally is the difference between Wally and this complex number, the distance, because I'm saying distance because of these mods here. The distance between Wally and that complex number must be the same distance, because it's equal distance because of the modulus, and this is between Wally and that complex number in the picture must be the same as that one. So we need a picture with those 2 points on, don't we? So we've got 9i, so that's the imaginary axis. So we'll have a 9 on there. And then we've got the real axis. And we've got, so that's that point. And this point's 12 along, 0 up. So it's there. So basically, Wally must be the same distance away from that point as he is that point. So in the middle there, it could be here, anywhere on this, what they call that perpendicular bisector. Now to find that perpendicular bisector, or to draw it, you could use your compasses, pair of compass and do that business, but I'll not do that. What I'll do is find the midpoint of that line first. So if I can find the midpoint of here, I know it says only to draw it, but we might do it properly. So the midpoint will be halfway between those 2 points. So we've got basically 0 plus 12 over 2, that's the x coordinate, and the y coordinate would be 9 plus 0 over 2. So basically the midpoint is 6, 4.5. So Wally could be at 6 along, 4.5 up. Now, it could always also be on this, what they call perpendicular bisector. Anywhere on that line there, W could be anywhere, because anywhere on that line is still the same from the 9 and the 12. 12 seems to have disappeared there, it's 12. So, because it's just draw a line, you can just draw a line, but let's say they asked you to work out the equation of that line just in case. Right, you know it's 90 degrees to this line that joins 6 and 9 and 12, so we know it's perpendicular to that one. So if you find the gradient, grad of line joining, that's not joining, 0 plus 9i to, oops, pen's rubbish, to 12 plus no i's. That's changing y over changing x, isn't it? So changing y is, if you like, 9 take nothing over changing x, nothing take 12. So that's minus 3/4. So that's that line. Got me thingy on. That's that line. That's the gradient of that line. So our gradient, so this bisector, is, so perpendicular bisector, bisect has gradient, remember it's the negative reciprocal, so it's 4/3. Happy with that? So it's got a gradient of 4/3. We know it goes through this point, the midpoint. So you can do that y minus y1 equals m over x, times x minus x1, and x1 is 6. And you can just rearrange that and get the actual equation of that line if you wanted to. What would that be? Well, that leads us to, well, then I'll shut up about this one. Y equals 4/3x. I'll have to do a bit of times in on my calculator. It is Friday night. 4/3, will that be 24 divided by 3 is 8, isn't it? 2, yeah, 8. So it'll be minus 8. Can't do it in my head. Minus 8 and add 4.5. That's 3.5, isn't it? I think it's 3.5. So that would be, yeah, minus 3.5. If you want, you can roll that 7/2. Was I wrong on that? Just check with my calculator, because I say it is Friday night. God, this calculator's rubbish. Get on. Six. Oh, I can't be bothered with the calculator. 6 divided by 3 is 2. 4 is minus 8. Yeah, it's right, isn't it? 3.5. That'll be good. Right, had enough of that. So basically, it's crossing here, if you needed to label anything, at 7/2 or minus 3.5. And it's got a gradient of 4/3. Right, so we've done that in probably too much for it for 3 points. They probably just want you to draw the line. Nice to show the midpoint though. 6, 4.5. But we found the equation of it as well. Extra. Next thing, the locus L2 consists of the points representing complex number z, for which that is that. So it's very similar to the one above, except for there's a 2 in front of the other. So that basically means that Z, who call him Zebedee, is, let's put him on the diagram as well. Let's make him purple. So Zebedee is the distance from 9 is twice that it is from 12. So he'd be about here basically, because that is twice as long, that distance here is twice as long as that distance there. But it'd be a nice, so he's there, is Z. Could be there, let's put it that way, or it could be in different places. It looks like it'd be the line, bisector line, but reading on it says by writing, I think it's another bisector, but as I say, by writing Z equals X plus IY, where X and Y are real, obtain an equation relating X and Y, and hence show that line 2 is in fact a circle. Well, locus 2 is in fact a circle, not a bisector line again. And give the centre and radius of this circle. Right. New sheet. There's the question again. So basically just told me to write in X plus IY where I see a Z. Right, we know these are the modulus brackets. That's a bit of like Pythagoras, doesn't it? It means just square the reals, square the imaginaries, and square root. So let's gather the reals together. So that's just x, which means x squared and then square rooted all of it, plus the imaginary squared, which would be y minus 9 all squared. Oops, we don't really need these on now because I'm dealing with the modulus, aren't I? Let me rub this. That's what modulus means. And then we've got that equal to 2 square root. So we're dealing with the modulus. The reals x minus 12 all squared plus the imaginary squared. So all I'm really doing is Pythagoras, because you're doing like the length. Well, you probably know what I'm on about. So square both sides. So I'll get x squared plus y minus 9 all squared equals, that thing's not squared, so I have to square that 4, and then lots of, do another bracket, x minus 12 all squared plus y squared. So basically just got rid of the square roots. I have to square that one though. Next, just a massive expansion now really. X, I'll try and make it small, x squared plus y squared minus 18y plus 81 will equal 4 lots of x squared minus 24x plus 144 plus y squared. We'll expand that lot. X squared plus y squared minus 18y plus 81 equals 4x squared minus 4 times that, 96 I hope. 4 times 144, yeah, 576, I think, yeah, 576, and plus 4y squared. Bring them all over one side, so put 0 there. How many x squareds have I got? Well, I've got 3x squared. I've got, how many x's? Oh, x is only 96, minus 96. And I've got y squared, bring that over. So I'll have 3y squared, and I'll have plus 18y. And the constant, I can group those two together. So 576 minus 81. 576 minus 81 equals 400. So it will be, yeah, minus, but plus 495. Let's divide by 3. It's equal to 0, so let's divide everything by 3. So 0 divided by 3 is 0. So we've got x squared minus, that divides by 3. How many times? 32. Plus y squared, divide by 3, plus 6y, and divide by 3. Calculator check. Yeah, 165. Right, sure, I'll go up here. So now it's basically a bit of complete the square. We're looking for a circle. So we've got x minus half of the x coordinate 16 all squared, and that would generate a 16 squared that we haven't got, so we'll take that away. 16 squared is, should know that, shouldn't we? 256, so minus 256, and then we'll do the same with the y, so plus y minus half the y coordinate, oh it's add 3, all squared, that'll generate a 9 I haven't got, so I'll take away that. And remember I've got this plus 165 going on. On the machine, let's do minus 256 and a minus 9 and an add 165. That's going to leave me with 100. Well, negative 100. So I'll take that negative 100 over here. So I've got 100 equals x minus 16 all squared plus y plus 3 all squared. And then you can see it's like the equation of a circle. The centre is 16 minus 3, and the radius is square root of that thing, which will equal 10. Lovely. I think we finished that. And then there was a part C, turn over. Hence write down the equation of L2 in which Z occurs only once. So it wants you to put it back in like loci form. So we've got a circle with centre. Can I remember? Was it 16 minus 3? Hopefully, because I can't turn back. And the radius was 10. So to write a complex number in a circle, if you remember that, Z, the difference between Z and this complex number, it's not really a complex number at the minute, but it's X and Y. So that will be 16 minus 3I. The distance between that and that will always equal 10. So basically you've got your centre 16 along and 3 down, and the thingy must be 10 away from that, so like anywhere on that circle that goes around there, and that's L2. And I've missed off there, I shouldn't have written that, should I? Yeah, I should. Minus the complex number. Yeah, that's right. So that would be our answer. Hopefully that makes a bit more sense than what you thought. It'll puzzle Vicky anyway. See you for now.